Right, so step one is to get the casting sort of indicated in the chuck, and this is a fairly small casting, so I'm not using my 4-jaw, instead I'm using a 3-jaw, and there's enough meat on the casting where it doesn't have to be running, completely true, which no 3-jaw ever is. So I'm just basically indicating it by eye and using the tool to make sure it's running parallel to the face of the chuck. And here we are beginning the first facing cuts. Now this is a little bit of a dicey process because this is a very heavy interrupted cut because I'm facing the hub of the wheel, so I'm taking this slow, only taking off maybe 10, 15 thousandths at a time, and I will feed that all the way in until it's cleaned up across the face of the hub, and then I will go in with a center drill and then number drill, which is the interference fit size for 3/16. There we are, just finishing the hub. So now we will put in the ye olde Jacobs chuck and start drilling our hole. Now we are beginning to drill the hole. Now I will say that this footage is sped up. I'm not actually running the lathe at this speed. This is about twice the normal footage speed because otherwise this would be just a very boring video of a lathe going around several thousand times. But that is our hole drilled. And now we are ready to start facing the actual rim of the wheel. Now this is even slightly more difficult than the hub because these castings are from a very well-known manufacturer, but these ones happen to have a lot of chilling on them. And chilling on a casting, for those that don't know, is when the edge of the casting cools very, very quickly and it becomes very hard. It almost has a martensitic hardness, as they would say. So you have to use a lot of tool pressure to get the tool under the initial layer of sand and impurities that are on the outside of the casting. And we've gotten through that, and now we are turning the flange. And this flange has a roughly 2 to 2.5 degree taper on it. All railway wheels, a lot of people think they just rely on the flange of the wheel interacting with the head of the rail to keep them on the track. That's part of it, but a lot of what keeps them on the track is the fact that the tread of the wheel is actually tapered in a very gradual cone. It's in gauge 1, I use a taper of about 2.5 degrees. Full size practice it varies depending on the size of the wheel and what profile of rail they're running on. But I chose to use a 2 to 2.5 degree taper here, so I'm just putting that on now. And I believe this clip is playing at actual speed, so you can see what a long and tedious process this actually is, because cast iron does not like to be run at very high speeds, so I'm turning this quite slow and going in fairly frequently with the micrometer to see where we are on our measurement. This needs to be 1 inch 750 thousandths on the tread. That's at the narrow end of the taper. The wide end of the taper is a different number, but I'm shooting for 1 inch 750 thousandths at the narrow end of the taper. And you can also see that the lay shaft on my line shaft here, someone's obviously cut it off with a hacksaw at some point in time because it is not running particularly true. I'm guessing it was a much longer shaft when it started out its life, but I presume it's gone through a few different factories, so it's been shortened over time. And now we are ready to, I believe, yes, we're going to file off any burrs on the tread. Now, I know this looks very dangerous, but the camera sort of plays tricks here. My hands are not anywhere as close to the chuck as it may seem. And this handle has a file on it this file has a handle on it, so there's little risk of it, going back and going into my hand. And now I'm just sanding the burrs off with a bit of sandpaper, put a bit of polish into the rim of the wheel, which some people think this is a dangerous process, some people don't. I thankfully have never had any issues with it, and I find it works very well. But it is best to use an abundance of caution when sanding parts in the lathe. There we have one half of the wheel fully machined. So now I am going to flip the part around, put it back in the chuck, and I'm going to face off the back, which is, it's a fairly simple operation. The chilling was not quite as severe on the back of these castings, so it was a little easier to machine them down. And this is another sped up clip of that happening. But the keen-eyed of you might have noticed that the flange on this is significantly larger than it should be. So what I'm going to do is I'm going to put the drill chuck back in the tailstock, and I'm going to move the jaws all the way back, and I'm going to put it almost touching the casting, and then I'm just going to loosen it in the chuck, push the casting out to what registers on the drill chuck, and then I will have enough clearance behind the flange to turn the flange down. Which I will do after this operation. And this operation is sort of the money shot in all of this, which is where I go in with a trepanning tool. This is basically a big trepanning cut, and I'm going to cut out the remaining metal on the back of the casting so that you can see the spaces in between the spokes. And that's what gives the wheel its signature look, and lets you know that it actually is a locomotive driving wheel. And then I'll go back in with a file and clean up the flange and everything. And then we are all done. And it's over to the assembly bench to check our fit on the axle. There's the chassis there on top of the surface plate, and I'm just deburring each side of the hole with a little countersink here that is held in a old and somewhat beaten up Starrett tap wrench, which is missing its handle. We're going to test fit that on the axle. This is an interference fit, but I'm not pressing the wheels on all the way onto the axles because these axles are A, a little short, and B, they're all going to have to come off, get quartered, and they also need the crank pin holes drilled in them. So I'm not pressing them all the way on, just some of the way on, and I'm doing that in this, I believe it is a 1908 Parker Vice, which I dragged out of my old high school. I tell people it's the only good thing I got out of high school, and I'm not entirely lying there, but that wheel is now on, so it's over to the test track to see how well the chassis performs on the rails. I was a little worried this wouldn't go very well because I'm using scale size flanges here due to the very short distance between the first and second coupled axle. But as you can see, it does seem to hold the rails very well, which was very surprising to me, and I'm quite pleased with it. So there's the completed chassis, and thank you all for watching. Like, comment, subscribe. It does help the channel, and I hope you all enjoyed the video, and I'll see you next time.